Section 2.5 deals with solving different types of equations. And so this first type here would be an absolute value equation, and you're going to try to solve this. So to get x by itself, you have to get rid of the absolute value symbols, and so they just go away. And then the other side would become both positive 5 and negative 5. So anytime you get rid of the absolute value, then it's got to be both of these two. Now, if you had something like the absolute value of x equals a negative 2, that is not possible because you can never take an absolute value and get a negative number. So in an instant like this, when you get to that point and get rid of the absolute values, if this number over here is negative, then you would just stop and say not possible. So then for something like x plus 2, absolute value is equal to 7. So the first thing you have to get rid of still here are the absolute values. So then you would have x plus 2 equals both positive 7 and negative 7. And then the last thing you would end up doing is subtracting 2 from both sides. And then you would have x equals, and now you have to make sure that you do these two things separately. So 7 minus 2 is 5. And then also negative 7 minus 2 is a negative 9. And then finally, if you had an equation like this with absolute value and you were going to solve it, you would first have to add 7 to both sides to get 3 times the absolute value of x plus 2 equals 21. And then from there, you would divide by 3, and then you would have the absolute value of x plus 2 equals 7. Now you would get rid of your absolute values, and then x plus 2 equals plus and minus 7. And then finally, subtracting 2. And you would have x equals 5 and negative 9. So that's one type of an equation that you will see in today's assignment. Second type would be things with a square root. Something like this really isn't too bad. Just like with the absolute value, you have to get rid of that first. So to get rid of square root, you would square this side and square that side. And then you would have x plus 2 equals 25. Then from there, we would subtract 2 and get x equals 23. Now then, next type of question would be something like this, and it's similar to this previous question in that you have to square both sides, but here we have more than one square root. So we're going to have to do this a couple of different times. And so first thing, we square both sides. Well, squaring this right-hand side is no big deal. It's just going to be 5 plus x. Squaring this side gets to be a little bit more difficult. As you have squaring, it means you'd have 2 times the square root of x minus the square root of x minus 3. And then you'd also have another one of them. And so now if you're going to multiply this out, that times that is going to be 4x, because the square root of x times the square root of x is just x. Then when you multiply this times that, you are going to get a negative 2 times the square root of x times x minus 3. And then if you multiply that times that, you're going to get another negative 2 times the square root of x times x minus 3. And then finally, when you multiply those two things together, you are going to get plus, and the square root of x minus 3 times the square root of x minus 3 is x minus 3. And so we've gotten rid of some of the square roots, one of them. We still have 2 left. Now we can simplify this whole side, and we have 4x plus x, which is 5x, minus 3. And then negative 2 times the square root of x times x minus 3, and then negative 2 times the square root of x times x minus 3 is going to be minus 4 times the square root. And then we can multiply that together to get x squared minus 3x. And now that will equal 5 plus x. And so then we would have to move these things to the other side because we need to isolate the square root again. So we have to subtract 5x and add 3. And so then you would have a negative 4 times the square root of x squared minus 3x equals 8 minus 4x. Now then at this point, we can divide by a negative 4 and divide by a negative 4. And then we would have the square root of x squared minus 3x equals negative 2 plus x. And so now we can square both sides. And this will become x squared minus 3x. And when we square that, we're going to multiply it by itself. And so that would be 4 minus minus 4x and plus x squared, because that's a negative 2x and that's a negative 2x. So moving everything to the one side, if we subtract x squared, those are going to go away. And so then let's bring the 4x to the other side. And then we're going to get x equals 4. Okay? And then that's your solution. Now, when you have a square root, understand that in your solution, when you have a square root of anything, the domain for this is everything that is greater than or equal to 0. And if you substitute 4 into that, that would be okay. But if we had an equation that was that was in our original equation, well now if you take on x equals 4, if you substitute a 4 into this, 4 minus 5 is a negative 1. And so then the square root of a negative 1 is an imaginary thing, which is not going to be an answer for this. So then if that were the case, if you had something like the square root of x minus 5 in your original problem and solved and got this, well, because when you stick 4 in, it's not greater than 0, then this 4 would not be a solution anymore. And you would have to cross it out and then say no solution. Now, I don't think that will happen too often when you solve something like this, but it could. So just double check to make sure that this answer, when you substitute it into any part of the original equation for a variable, you still have a positive thing, and it is positive here, because square root of 4 is okay, and 4 minus 3 is 1, so the square root of 1 is okay, and if you put a 4 there, 5 plus 4 is 9, and you can take the square root of 9, so it's okay. You don't actually have to try to figure all that out. Just know that underneath the square root has to be something greater than 0, or equal to it. All right, then. In a previous section, you dealt with things like this, and you had to try to figure out the roots to it, so you factored it. So that became x plus 3 times x plus 2. And it still equaled 0, and then you could set each part equal to 0 and say x equals negative 3 and x equals negative 2. And that was the zero product property that allowed you to do that. Well, in factoring, the reason you can do this is because when you multiply this out, you get that. And just so you understand that, whatever this is, this exponent has to be half. That's 2, that exponent is 1. If that is some number and this is half of it, and then the last term is just a or a constant, then it can be factored. As long as that's 2 and that's 1, or if this is 8, then this would have to be 4, or if this is 18, then this would have to be 9. Anytime it's a situation like that, this same concept of factoring can still apply. So if you were looking at something like this, x to the 6 plus 5x to the third plus 6, well, yes, 6 is here, 3 is there, so it's factorable. And so now, what are the factors of 6 that get you to 5? And they would still be 3 and 2. But now instead of just writing x here, you would have to write x to the third and x to the third. And it'd still be plus 3 and plus 2. And then using your zero product property, you would say x cubed plus 3 has to equal 0, and x cubed plus 2 has to equal 0. And then solving this, x cubed would equal a negative 3, and then x would equal the cubed root of a negative 3. And here it would be x cubed equals a negative 2, or x equals the cube root of a negative 2. Okay? And so like if this was a 4 and then this was a 2, then you would have x squared and x squared. And then here you would have the square root of a negative 3 and the square root of a negative 2, which is something with an I. And if the question only asks for real solutions, then this one wouldn't have any solution if this was 4 and 2. But remember, with an odd root, you can take the square or a cube root of anything, whether it's positive or negative, doesn't matter. Even roots are the things that can't have negatives underneath it. And finally, a problem like this, which is similar to the one we just did, and for the purpose of making it easier on yourself, rather than having to figure out something to the 2/5 or the 1/5, say that a equals x to the 1/5 power. Then if you substitute, since a is x to the 1/5, that's like x to the 1/5 times x to the 1/5. And so that's like a times a, or a squared, plus 7a plus 12 equals 0. You can define a new variable to represent the variable you're trying to solve for. And since we have some fractional exponent, it's easier to look at this than it is that. And so now we can try to factor. And the factors of 12 that get you to 7 would be 4 and 3. And so then you would have a equals negative 4 and negative 3. Now we are not done with this problem because we're not trying to solve for a, we're trying to solve for x. So then once we get to this point, now we reintroduce the variable we need. So now x to the 1/5 power is going to equal a negative 4 and a negative 3. And then to solve for x, you would have to take this to the 5th power. And then you would have x equals, and a negative 4 to the 5th power is a negative 1024. And a negative 3 to the 5th power is a negative 243. And that would conclude the types of problems you are going to see in this next section, which is 2-5. So go ahead and start working on it. Have a great weekend. We'll see you next week.